Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on February 4th, 2026, just 6 days ago. It introduces a method that addresses the stateless nature of reasoning in large language models, essentially giving them the ability to remember successful patterns across different problems, which helped it achieve over 73% accuracy on the AME25 benchmark. The paper is titled Empirical-MCTS, Continuous Agent Evolution via Dual Experience Monte Carlo Tree Search. And, as we'll see later, the implications for scaling model intelligence without expensive retraining are quite significant. Figure 1 maps out the concrete workflow of the framework. It starts on the left with a query and the global experience library, feeding into the select and expand phase. Crucially, the process relies on the PEEMP reflexive optimizer shown at the bottom, which generates specific criteria and allocates weights to score different reasoning paths. This mechanism drives the central comparison block to evolve the meta prompt, and finally, the memory update agent on the right consolidates any new wisdom into the repository. So having seen the architecture, Table 1 quantifies how well it actually works by comparing performance on the AIME25 and MathArena Apex benchmarks. The baseline DeepSeek v3.1 Terminus model starts with 56.7% on AIME25 and scores 0 on the harder MathArena task. In contrast, the proposed method, shown in the bottom row, jumps to 73.3% on AIME25, outperforming strong competitors like Flex and LlamaBerry. It also achieves 4.17% on MathArena Apex, successfully solving problems where repeated sampling failed completely. Alright, following those accuracy gains, Figure 2 analyzes the cost-performance trade-off. The top chart focuses on MathArena Apex, plotting accuracy against inference cost. Here, the proposed method appears as a red star at the peak of the dashed Pareto frontier. It achieves over 35% accuracy for roughly $5. In contrast, GPT 5.2, sitting far to the right, costs over $12 but scores significantly lower. The bottom chart confirms this efficiency on the ARC AGI2 task, showing the system delivers frontier-level reasoning without the massive price tag. So having established the cost advantage, Figure 3 digs into the component contributions through an ablation study on AIME25. The solid red line at the top tracks the full empirical MCTS method, showing that accuracy scales continuously with more rollouts, reaching nearly 77%. By comparison, the orange dashed line shows that removing the meta prompt causes scores to flatten out after just 4 rollouts. Finally, the lower green and purple lines reveal that without the memory module or the evolutionary optimizer, performance degrades significantly and barely surpasses the gray repeated sampling baseline. Okay, while the previous figure dissected the internal components, Table 2 now lists the head-to-head performance against top-tier commercial models. The first row shows the method using Gemini 3 Flash, achieving over 35% accuracy on MathArena Apex for just $5.24. Compare that to GPT 5.2 in the second row, which costs $12 yet only scores about 13.5%. Even advanced models like Grok 4 and Claude Sonnet 4.5 struggle significantly here, often scoring below 2%. Alright, contrast that static snapshot with Figure 5, which plots how performance evolves on AIME25 as the system accumulates experience. The solid red line represents the full framework, showing a clear upward trend from about 63% to nearly 77%. By comparison, the orange dashed line removes the meta prompt, causing it to plateau early at roughly 67%. Finally, the purple baseline at the bottom remains flat, confirming that without the memory modules, the agent simply doesn't learn from its history. So, while the previous figure illustrated the resulting accuracy gains, Figure 4 tracks the underlying growth of the empirical memory repository that drives them. The chart plots the number of distilled experiences on the vertical axis against the rollout count on the horizontal axis. Starting from 0, the repository grows rapidly, reaching 110 experiences after just the first rollout. It continues to accumulate wisdom steadily, climbing to 311 experiences by rollout 8, confirming that the system continuously captures high-quality insights. Wrapping up, 2 takeaways stand out. First, adding memory to search enables models to learn continuously without retraining. Second, this allows efficient models to outperform much larger competitors like GPT 5.2 on complex reasoning tasks. It fundamentally shifts how we think about scaling intelligence. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.